Hello, hello. Welcome back to part five, the fifth and final part of this little investigation. So, we have determined the answer graphically. So, what I'd like to do now is to have a look at see if we can calculate the answer quite easily. And so that's what I'm going to do. And I'm going to just have a look at a quick little PowerPoint that we've done here. And we'll see how we go. Slideshow from the current slide. And yes, so we'll just back the truck up a little bit premature there. So find the coordinates x and y of the intersection point of two straight lines. And I've said the two straight lines are y m1x plus c1. So that would have a gradient and a y-intercept. And y m2x plus c2, which would be a different line. So it'd have a different gradient and y-intercept. Although the y-intercepts could be the same. The C1 could equal C2, but if M1 and M2 are equal, the lines would be in fact parallel, and so they wouldn't intersect. So there are going to be some situations in this particular situation where the lines don't intersect, and yes, we would maybe get no solution. So again, we might have to go with some data validation there. But I've shown that in previous videos and things how we might do that. We'll see if we get a chance to maybe do that in this one, if possible. So yeah, alrighty, let's get on with it. So yes, so at the point of intersection, the x coordinate and the y coordinate are the same. So if y equals then the two equations are the same. M1x plus C1 equals M2x plus C2 at that point of intersection. So so that's all well and good. So now we're just going to change the sign. I guess would be the quickest way of explaining this. So I've put all the x's on one side, so M1x stays where it is, minus M2x, and then we'll subtract C1 from both sides, C2 minus C1, and there we go. And then we factorize the left-hand side, x times M1 minus M2, and then we divide through by M1, M2 to give us the nice little formula there. X equals C2 minus C1 over M1 minus M2. So let's have a look at the specific case of our examples in our graph there, 3x plus 1 and y equals negative 2x plus 6. Let's look at that specific case. So we can see there that putting it together, x equals C2 is 6, C1 is 1, 6 minus 1 over 3. That's M1 is 3 and M2 is negative 2. So 3 minus negative 2 is 5, over 5 is 1. So we've got x equals 1. What does y equal? Well, we've got two equations, each of us telling us what y is equal to. So, well, let's do it both ways. X equals 1. When x equals 1, y equals 3 times 1 plus 1 equals 4 in the first equation, and negative 2 times 1 plus 6 in this equals 4 in the second equation. So we are able to say without a shadow of a doubt that the lines intersect at the point 1, 4, which our graphical solution showed us. Bloody good. All right. So let's go back to our graphical one here, and here it is here. And what I would like to do now is to record that up here. So I think I'll just maybe try and get it here somewhere. So I'll just go over to here and copy our formula like that, I hope. Is that going to copy it? Control C. So let's see how we go, and back to here. And I think we better put that in a text box. So insert text box here. Right, and we'll just put a little text box here. Control V. Oh, there it is there. It's a wee bit tiny, isn't it? Yeah, so, it's just make it maybe 20 or something. Maybe a bit bigger. There's our formula. 32. Oh, oh no, just got to make our text box a bit bigger. There it is. There it is. So x equals C1. That might be a wee bit big, I think. So at intersection. Okay, so let's put that there like that. Yeah, I think that's a bit big. We'll make that a bit smaller. 18 perhaps, or maybe 20. There we go, 20. Okay, at the intersection, and we'll just put that in there like that. Okay, and right now in here, now I might just so our point of intersection is, and I might just turn on some grid lines here just as a bit of a help. Yeah, okay, that's better. Okay, right, maybe here. Point of intersection equals, we'll just put that in there. Maybe put that in the middle of the home, in the middle there, right. And then we just got to put a formula in here. So and we can use our little formula up there for x, and right, so let's put our little formula, point of intersection, or maybe here. Just merge all those, merge and center. Oh, that's a little bit better. And then we can put our point of intersection here. So we're going to go equals, quote, yeah, I want to put a bracket and thing there. Be the better way to do it. Point of intersection. I'm just thinking whether we do it that way or just put x. I'll just put x equals. I think that's going to be easier and give us more flexibility. X equals. So we'll put that in the middle like that. And so x is going to be 2. Right. X is going to be there. Like so. Righty. Okay, x is going to be equals, and it's going to be C2, which is CCC, I think, CCC, minus C1, which is CY. We'll just put those in a bracket. Okay. No. In the bracket. Okay. Right. And yep. Divided by. So that's C2 minus C1 over M1, which is M. Yep. And minus mm. Okay. And we want to put a bracket around both of those. And that should be 1. Okay. Let's put that in here in the middle. And we'll just give that, just give it 1 there. And we're going to go y. And that'll be y equals bracket y equals, yep, and we'll just copy the format for this here to there. All right, and it's just we can use, I'll use the first formula there, equals m times that plus that. Oh, no, that's not right. M times that. What am I talking about? Equals that m times, it's actually maybe easier to point, times that plus that. And that's 4, and that goes there, like that there. Let's copy that to there. Format painter, yeah, put that in there. Okay, point of intersection, and I was maybe, yeah, just trying to fit it all in here. Such a good idea. Okay, yeah, and maybe I could make this a little bit smaller, just to, make that maybe 14 or something. Yep. Okay, so that's our, yep, like so, and then we can put this, or this here, Control X, there, enter, and then in here, merge and center. In here we'll put equals bracket bracket that there and that and comma that and that and bracket that. Okay, and okay, now there's some Yeah, so we want that equals to move over a little bit there. So we can put 1, 2, 3, 4. Okay, a little bit more, maybe a couple more. One more. Just one more. Or two. There we go. Yeah, and probably a little bit in here as well. Yeah, that's all good there. Now, obviously, there's a lot of data validation and stuff that needs to go on to get this one sorted. Like, obviously, we need to do some rounding in here, and maybe in a situation like, for instance, if this here was -2, you could see you'd get an error in there. So, yep. Right. So, yeah, we'll just try a little bit of data validation here. So, let's put a little function in here. So go there, and we'll put an if error in there. Yeah. Enter. Okay. Okay, and then we'll push this here to give us the wizard. Logical tests. That should be slash slash. It should be there. Right, so we've got to work on this now. What's happening there? Okay. This doesn't seem to be. Okay. No, we've got all screwed up here. Let's just go Control Z how to deal with this now. Escape, escape, escape. Right. Escape. Control Z. Okay, so we're all good there. What we need to do here is I just want to copy that. I wonder if I can copy that. Control C. Delete. And then if error. And we'll push the this here. It should give us that if error. Okay. No, it's not what I want. Delete. Right, here. There we go. And we want to put in there if error. Okay. So this is the value, which I Control V. If that there, enter if value, if error. In this case here, we'll just put nothing. Okay, like that. Okay. Right. And yep. And then for this one here, I'm going to do the same thing. I'm just going to copy that. Control C. Right. And then we'll just delete everything. And then we'll put if error in there. Formula of insert recently used. If error. Okay. And we'll just type that back in. There. And if there's an error, just put nothing. So that way nothing. Oh, so that's just a quote space quote. Okay. Right. And then here, we'll copy that. Right. We'll delete that and we'll put an if error in there. Equals if error. Okay. Click on that. All right. If error. Okay. Oh, puts it in twice. Oh, we can take all that out there. Okay, value, we'll put that one back in, Control V. Value if error, no solution. Okay, so we've got I think that equals got to come out of there. Okay, how's that looking? Okay, so then if these two here, if we make that -2, oh, okay. Right. That there that's coming. I see what's happening there. Well, it's considering that to be a solution, so it's not an error. If we go back to these ones, so yeah, it's got to edit these. Oh, these here. Yeah, no, we just put ooh. We don't have to put the error in there. We can just leave it, just leave those at this stage. I mean, there is something I'll just, oh no, that's not right. Control Z. Okay. These here need to just be left alone, I think. Yep, and we'll just put that like that. Okay, right, and this one here as well, like that. And error. Okay, oh, okay, and that's good like that. Now if we go here, put -2 in there, we get those no solution. Yeah, and yeah, I think I'll just leave that like that. Or yeah, we can. There's other better. Maybe we can do different things with that. But yeah, that's just if they are parallel, or well, if they're parallel really, and so there's no intersection. So now we can start looking at other intersections, maybe 5x plus 3, and it'll give us all sorts of things. So -5 in there and 1 in there, like so. And you can see there's the intersection. So it's at 0.22, okay, for that one. So I'll go back to our original one, which is Control Z, 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 like that. And that's our one there. So yeah, a little bit of validation and tidying up. Oh, that there needs to be outline, no outline. And I'll turn off these lines like that. And you could turn off the formula bar, which is that there, and you could turn off the headings, and yeah, there it is. So just a nice little conclusion there. Obviously, there's some data validation needs to be done and some stuff needed to be sorted out. But, you know, for just nice, tidy, simple graphs, I think we can see. And if we've just got a simple one in there. So if we make that 3 there, the graphs will be parallel. You can see you get that there, no solution. Or maybe that would be better. Let's just... oh, I need to put the formula bar back in there now. And yeah, no solution. Maybe no intersection might be better. No intersection. Yeah. Okay, so that's good there. And yeah. Yeah, if we put an error in there, because this here is going with no intersection. If error, yeah, no intersection there, but it won't. Okay, wouldn't create an error if it was blank. Interesting. Anyway, that's these are all part of these investigation things. So the whole purpose of these little exercises is to investigate. So we learn a little bit about Excel, where we can go, planning forward, how we can improve, what we need to work on, and yeah, that sort of thing. So I should really put this back to what I had, I think, which was no. What did we have? -2. -2. -2 was our sort of example. So yeah. And this is just shows us some of the things that we can do, and we're continually improving, and we should have a good idea of what we want, and you know, we've got to remember to test it, and you know, little bugs will come out as part of the testing process as well. So yeah, there you go. I think that ends this little series of yeah, investigating linear equations and lines and things. Thank you very much for your, if you've made it this far, you're a bloody champion. Yeah, bloody marvelous.